If you're a C# developer, you already know that waiting for nightly batch jobs just doesn't fly anymore. Your users want everything, and they want it now. Well, that's exactly what we're going to build today. We are going to take Apache Kafka and plug it right into a C# web app, step by step.
So here's the game plan. First, we'll do a super quick rundown on why real-time data is such a big deal. Then we'll meet our star player, Apache Kafka. After a quick setup check to make sure all our gear is ready, we're diving straight into the code. And finally, we'll talk about all the cool stuff you can build with this new power.
Okay, let's just start with the obvious. The world moves fast, and your app needs to keep up. We can't wait around for data to be processed in batches overnight. To build an app that feels alive and responsive, you've got to handle information the very second it's created. That's the whole idea behind real-time data.
So, why is this so critical? Well, think about it. We're talking about fraud detection that stops a bad transaction as it's happening, not after the money's gone. Or, live dashboards that show you what's going on in your business right now, not what happened yesterday. The magic is in the speed, and that's exactly the kind of problem Kafka was built to solve. So, how in the world do we handle this constant, massive flow of information? Well, that brings us to the main event, Apache Kafka. Look, if your data is a massive, roaring river, think of Kafka as the high-tech, industrial-strength canal system that tames it and gets it exactly where it needs to go, reliably and crazy fast. Now here's a super important point. Kafka isn't just another message queue. It's a distributed event streaming platform. I know, that's a mouthful, but what it really means is that it was designed from the ground up for a non-stop flood of data, and it was built to handle it without breaking a sweat, even if servers fail.
Kafka's whole design really comes down to just a few simple ideas. You've got a producer, that's your C# app, for example, and it sends out messages. It sends them to a specific topic, which is kind of like a named channel or a log file. That topic can be split into partitions to handle more load. And finally, you have a consumer, another app that tunes into that topic to read the messages. That's it. Producer sends to topic, consumer reads from topic.
Okay, that's plenty of theory. Let's get our hands dirty and actually build something. But first, before we write a single line of C#, here's a quick pre-flight checklist to make sure your environment is ready for takeoff.
Don't worry, the setup here is super simple. Number one, you obviously need Kafka itself installed and running. Number two, we're gonna need to grab the official Confluent.NET library. It's just a quick NuGet install. And number three, you should be pretty comfortable with building a basic C# web app. If you've got those three things down, you are good to go.
All right, time for the main event. Let's build this thing. And trust me, it's not nearly as complicated as it might sound. We're going to do this in just 3 straightforward steps. First things first, we need to create a channel for our data to flow through. It's like paving a new lane on the data highway just for our messages. In the world of Kafka, this is what we call a topic. So you're going to pop open a terminal, go to your Kafka installation folder, and run a command that looks just like this. We're just telling it to create a new topic called My Topic. And for now, we're keeping it simple with one partition and one replica, which is perfect for running on your local machine. Oh, and of course, if you're on Windows, just use the .bat script instead. Okay, our data highway now has a lane. It's time to fire up Visual Studio and switch over to C#. We're now going to build the app that actually listens for messages on that topic, our Kafka consumer. And before we write any real code, we need the right tools for the job. Just open up your NuGet Package Manager console inside your C# project and run this command. It'll pull down the Confluent.Kafka library, which has everything we need to communicate with Kafka.
This little bit of C# code is the heart of our consumer. The Bootstrap servers part is easy. That's just pointing to our local Kafka server. But check out that group ID. This is actually really powerful. Kafka uses this to keep track of consumers. If you started up, say, 5 copies of this app with the same group ID, Kafka would be smart enough to automatically spread the work between them. It's how you get that awesome scalability.
So, at this point, our C# app can pull messages from Kafka. That's cool, but just printing them to the console isn't all that useful, is it? For our final step, let's connect the last dot and get this data flowing right into our live web application.
And you won't believe how simple this is. Inside our consumer, where it receives a message, we're just going to add a standard HTTP client. That's it. For every single message we get from Kafka, we just turn around and immediately post it to an API endpoint on our main web app. Simple, right?
So the last tiny piece of the puzzle is your web app itself. All you need to do is add a simple API controller with an endpoint, something like /receive-message, that's ready to catch the data that our consumer is throwing at it.
And that's it. Just like that, you have a complete working data pipeline. We've got a Kafka topic feeding a C# consumer, which is pushing data directly into a web API. Let's just zoom out for a second and think about what this really lets you do. Seriously, take a moment. This is a huge deal. You've just unlocked real-time data flow for your application. You're no longer stuck constantly asking the database, is there anything new yet? Now your app can just react to things as they happen anywhere in your entire system.
You now have the fundamental building block for making your apps feel truly alive. We're talking live updating dashboards, instant push notifications, or maybe even a whole system built on event-driven microservices. You've laid the foundation, so the only question left is, what are you going to build with it?